Yes, coaxial cable is permitted to be installed in the channel along with the non-metallic sheath cable. The term conductors in section 820.133a in ETWA refers to the individual conductors within the cable, not the entire cable assembly. Coaxial cable is considered a conductor as it contains a center conductor, an insulating layer, and a shield. The correct wording for exception number 1 is non-metallic sheath cable or type AC cable. The comma is not present in the 2023 National Electrical Code. This exception allows either a single non-metallic sheath cable or type AC cable to be installed in the channel. Non-metallic sheath cable is a type of non-metallic sheath cable. Type AC cable is a specific type of armored cable that is suitable for use in the channel. Therefore, exception number 1 permits the installation of a single non-metallic sheath cable or a single type AC cable. Section 820.133 covers cables within buildings, specifically network-powered broadband communications cables. Subsection addresses the types of cables permitted. Paragraph 1 states that only listed broadband communications cables or other cables along with listed raceways are allowed. Paragraph 2 delves into uses not permitted, stating that broadband communications cables must not be installed with non-power limited fire alarm circuits or medium power network-powered broadband communications circuits. Exception number 1 addresses the allowance of non-metallic sheath cable or type AC cable, which, as previously stated, is permissible. Section 800.133 covers similar ground, but for communications wires and cables generally. The structure is the same. Subsection A discusses permitted cables, while subsection B lists uses not permitted. Exception number 1 in this section also allows non-metallic sheath cable or type AC cable. It's important to understand the definitions. Broadband communications cable refers to coaxial cables used for transmitting television, internet, and other communication signals. Non-metallic sheath cable, commonly called NM cable, is a type of electrical cable used for interior wiring. Type AC cable, or armored cable, is another type of electrical cable with a flexible metallic sheath protecting the conductors. When installing cables in channels, always consult the latest edition of the National Electrical Code and local regulations. It is crucial to follow all applicable codes and safety standards to ensure a safe and compliant installation. If there is any doubt, a qualified electrician should be consulted. It's important to distinguish between conductors and cables. A conductor is a single wire or strand of wire used to carry electrical current. A cable is an assembly of two or more conductors held together by a jacket or other means. In the context of section 820.133 in ETWA, the term conductors refers to the individual wires within the coaxial cable or the non-metallic sheath cable. The coaxial cable itself is considered a cable assembly, but it contains conductors, namely the center conductor and the outer shield. When the code refers to the installation of conductors in the channel, it means that the individual conductors within the cable assembly must be suitable for the environment and comply with the relevant requirements. The exception allowing non-metallic sheath cable or type AC cable clarifies that these types of cable assemblies are permitted in the channel under certain conditions. Consider a typical residential installation. A Florida room, as described, often has limited space for running electrical wiring and communication cables. Channel along the bottom of the wall provides a convenient pathway for these cables. In this scenario, it's common to run both electrical wiring, such as non-metallic sheath cable for lighting and outlets, and communication cables, such as coaxial cable for television or internet. According to the National Electrical Code, it's generally permissible to run these cables together in the same channel, provided that they meet certain requirements. Firstly, the cables must be listed and labeled for their intended use. This means that they have been tested and certified by a recognized testing laboratory to meet certain safety standards. Secondly, the cables must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. This includes ensuring that the cables are properly supported, protected from physical damage, and separated from other cables or equipment that could cause interference. Thirdly, the channel itself must be suitable for the installation. It should be large enough to accommodate all of the cables without overcrowding, and it should be made of a material that is compatible with the cables. For example, if the cables are rated for wet locations, the channel should also be rated for wet locations. It is also necessary to consider voltage drop. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. To minimize voltage drop, it's important to use the correct size of conductor for the application. The National Electrical Code provides tables and formulas for calculating voltage drop, and it's important to consult these resources when designing an electrical circuit. Proper grounding is also crucial for electrical safety. Grounding is the process of connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. This helps to protect people from electric shock and prevents damage to equipment. The National Electrical Code requires that all electrical equipment be properly grounded, and it specifies the methods for grounding different types of equipment. In addition to these general requirements, there may be specific requirements for installing cables in Florida rooms. For example, some local codes may require that all wiring be installed in conduit, which is a type of protective tubing. It's important to check with the local building department to determine the specific requirements for your area. Here are some additional tips for installing cables in channels. Firstly, plan your installation carefully before you begin. Determine the location of all outlets, switches, and other equipment, and map out the route of the cables. Secondly, use the correct tools and equipment. This includes wire strippers, crimpers, fish tape, and other specialized tools. Thirdly, be careful not to damage the cables during installation. Avoid bending or kinking the cables, and do not pull them too tightly. Fourthly, test the installation after it is complete. Use a multimeter to check for shorts, opens, and other problems. Fifthly, label all cables and wires clearly. This will make it easier to troubleshoot problems in the future. Following these tips will help to ensure a safe and compliant installation. It's always a good idea to consult with a qualified electrician if you have any questions or concerns. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years, and it's important to stay up to date with the latest edition. The National Electrical Code is published by the National Fire Protection Association, and it is available for purchase online or at most bookstores. It's also possible to access the National Electrical Code online through a subscription service. Studying the National Electrical Code carefully is a great way to learn more about electrical safety and best practices. In summary, coaxial cable is permitted to be installed in the channel along with non-metallic sheath cable, provided that all applicable codes and regulations are followed. The term conductors in section 820.133a network refers to the individual conductors within the cable, not the entire cable assembly. Exception number 1 allows either a single non-metallic sheath cable or a type AC cable to be installed in the channel. Always consult the latest edition of the National Electrical Code and local regulations before starting any electrical work. Remember to consult with a qualified electrician if you have any questions or concerns. Proper planning, using the correct tools and equipment, and following all applicable codes and regulations are essential for ensuring a safe and compliant installation. It is also important to consider voltage drop and grounding when designing an electrical circuit. By following these guidelines, the safety and reliability of the electrical system are improved. When working with electrical wiring, always turn off the power at the circuit breaker before starting any work. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical wiring when you are wet or standing in water. Be aware of the location of overhead power lines and avoid contact with them. If you are not comfortable working with electrical wiring, hire a qualified electrician. Always follow the manufacturer's instructions when installing electrical equipment. Do not overload electrical circuits. Use extension cords safely. Inspect electrical cords and plugs regularly for damage. Replace damaged cords and plugs immediately. Keep electrical equipment away from water. Do not use electrical appliances in the bathroom or near a sink. Teach children about electrical safety. Supervise children when they are near electrical equipment. By following these simple safety tips, people can help to prevent electrical accidents. Additional points to consider include the ampacity of the conductors. Ampacity is the current carrying capacity of a conductor. The National Electrical Code specifies the ampacity of different types of conductors, and it's important to use conductors that are rated for the amount of current that they will be carrying. The temperature rating of the conductors should be considered. Conductors are rated for different temperature ranges, and it's important to use conductors that are rated for the environment in which they will be installed. The type of insulation on the conductors matters. Conductors are insulated with different types of materials, and it's important to use conductors with insulation that is suitable for the application. The number of conductors in a raceway matters. The National Electrical Code specifies the maximum number of conductors that can be installed in a raceway, and it's important to comply with these requirements. The density factors for conductors in a raceway is important to consider. When conductors are installed in a raceway, they may need to be derated to account for the heat that they generate. The type of raceway used matters. There are many different types of raceways available, and it's important to use a raceway that is suitable for the application. The grounding and bonding requirements for electrical systems matters. The National Electrical Code specifies the grounding and bonding requirements for electrical systems, and it's important to comply with these requirements. Surge protection should be considered. Surge protection can help to protect electrical equipment from damage caused by power surges. Arc fault circuit interrupters are important. Arc fault circuit interrupters can help to prevent electrical fires. Ground fault circuit interrupters are also important. Ground fault circuit interrupters can help to protect people from electric shock. Regular electrical inspections can ensure that the electrical system is safe and up to code. A qualified electrician can perform an electrical inspection and identify any potential problems. Addressing electrical problems promptly can prevent electrical accidents. Ignoring electrical problems can lead to serious consequences, such as electric shock or fire. Staying informed about electrical safety is important. There are many resources available to help people learn more about electrical safety, such as the National Electrical Code, the Electrical Safety Foundation International, and the Consumer Product Safety Commission. These guidelines and considerations are important for ensuring a safe and compliant electrical installation.